perpendicular to the tangent. Starting with a very beautiful sum which is supported with a figure. Here we say O is the center of the circle and BCD is a tangent to it at C. Prove that angle BAC plus angle ACD is equals to 90 degree. Let's try to understand the sum again. We have a circle with center O and BCD is a tangent at point C. So C becomes the point of contact. We need to prove angle BAC, which you can see it's blinking over there, plus angle ACD is equals to 90 degree. This is what we need to do with these two angles. We need to show the sum is equals to 90 degree. Now here the given tells us that line BCD is a tangent, and for a tangent we need to have a radius. So let's draw segment OC, which is the radius. Now because we draw segment OC, let's see what we understand further. OC and OA, they now form a triangle OCA. Now if you look at triangle OCA, that is in triangle OCA, we see that OA and OC are definitely equal. OC and OA are equal because their radii have the same circle. Now what happens if two sides of any triangle are equal? It is definitely an isosceles triangle. That means the angles opposite to them are also equal. So we now say angle OCA is equal to angle OAC, angles opposite to equal sides. So we now understand that angle OCA is equals to angle OAC. Angle OCA, just check. Now since we need angle BAC in the question, can angle OAC be written as angle BAC? The answer is yes. So what we do is, we write angle OAC as angle BAC. Let this be result number 1. And the reason should be B dash O dash A. So this is what we could understand from the question and because of the construction. But if you look at the question, we need to prove the sum of two angles is 90. Talking about 90 degree, observe angle OCD. Angle OCD has one arm as a tangent and second arm as a radius, and we know radius is perpendicular to the tangent. That means angle OCD is equal to 90 degree. That's what we're going to write, that angle OCD is 90, radius is perpendicular to the tangent. But here children, in the two proof, we require sum of two different angles to be 90. And on the same lines, if you look at angle OCD, it's again made up of two different angles, angle OCA and angle ACD. So we now say angle OCA plus angle ACD is equal to 90, angle addition property. But what can we do with angle OCA, which we don't want in the two proof? Angle OCA was originally equal to angle BAC from 1. So it's very simple. We can just write angle OCA as angle BAC, and we can write the reason is from 1, and that's what we need in the two proof for this sum. Let's take one more beautiful sum. Here, the sum is not supported with a figure. So reading the question properly is very essential. Prove that the angle between the two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the points of contact at the center. Very challenging. Here, one thing is very clear, we need to have a circle. So in the given, we write a circle with center O. We need to have an external point. So we'll take one point as P, which is in the exterior. And from this point P, we need to have two tangents to the circle. We'll take the tangents as PA and PB drawn from P to the circle. Here one thing is noteworthy, that A and B are the points of contact for the tangent and the circle. Here we need to talk about an angle. The angle which is between the two tangents. We are talking about angle APB. And we are going to talk about one more angle which is subtended by the line segment joining the 2 points of contact at the center. If we join the points of contact, that is A and B, we get a segment AB. And segment AB will subtend an angle at the center, and that angle has to be angle AOB. So here, the two special angles that we are talking about are angle APB and angle AOB. But what to do with these angles? We need to prove they are supplementary. That means the sum of these angles has to be 180. We need to prove angle AOB plus angle APB is equals to 180. Let's see how do we start. Here, the two angles which we are talking about, they belong to a quadrilateral. Let's consider quadrilateral APBO. Now, in this quadrilateral APBO, there are two angles which are special angles. We're talking about angle OAP and angle OBP. Since line AP and BP are the tangents and we know radius is perpendicular to the tangent, both these angles, angle OAP and also angle OBP, will measure 90. So we write down angle OAP and angle OBP are 90. Radius is perpendicular to the tangent. Let this be result number 1. Further, in this quadrilateral, when we add all the 4 angles, the sum is 360. So we now say angle OAP plus angle APB plus angle OBP plus angle AOB is equal to 360. Further, we'll substitute the values. We say 90 plus angle APB plus 90 plus angle AOB is equal to 360. We got it from 1. 90 plus 90 is 180. Hence, angle APB plus angle AOB is equal to 360 minus 180. And 360 minus 180 is definitely 180. Hence, angle APB plus angle AOB is 180 degree. And that's what we need to prove in this question.